Hello guys, welcome back to the channel No Mystery Science. Before I start this video, I would like to ask to subscribe and like this video. You're gonna help me a lot. So, continue our review of vectors. I have this exercise: determine the magnitude of the resultant force acting on the pin and its direction measured clockwise from positive axis. So first, I'm gonna find my components of my forces. Starting with F1 in x-axis, I have F1, that's my magnitude, times cosine of 45 degrees. So my F1x is equal to 30 times cosine of 45 degrees. My F1x is equal to 21.2 pounds. Doing the same process for F1y, I have F1 times sine of 45 degrees. F1y is equal to 30 times sine of 45 degrees. So my F1y will be 21.2 pounds. Doing this for our vector number 2, I have here F2x, and pointing down I have my F2y, so my F2x will be positive F2 times cosine of 15 degrees. I have F2x is equal to 40 times cosine of 15 degrees. My F2x is equal to 38.6 pounds. Doing the same process, I have F2y is equal minus F2 times sine of 15, minus because I'm pointing down, so my F2y is equal minus 40 sine of 15. My F2y is equal minus 10.4 pounds. My F3 will be a little bit different because now I have the angle with the y-axis, so my force in x will be positive and opposite, so will be sine of 15, and my y is gonna point down and gonna be cosine of 15. So here I have F3x is equal F3 times sine of 15 degrees. F3x is equal 25 times sine of 15. My F3x will be 6.47 pounds. My F3y will be minus F3 cosine of 15 degrees. F3y is equal to 25 times cosine of 15. F3y is equal minus 24.1 pounds. Now I have all my components. I'm gonna find my resultant force in our step number 4. I'm gonna find the sum of the forces in x, that will be F1x plus F2x plus F3x. My sum of forces in x is equal to 21.2 plus 38.6 plus 6.47. So my sum of forces in x will be 66.3 pounds. Now I'm gonna do the sum of forces in y direction. I have F1y plus F2y plus F3y. I have the sum of forces in y is equal to 21.2 minus 10.4 minus 24.1. So I have the sum of forces in y direction is equal minus 13.3 pounds. Now that we know our sum of forces in x is 66.3 pounds and our forces in y is equal minus 13.3 pounds, we know that our vector, here's x, here's y, I know my vector has an x component here and a y component here. So I'm gonna do my vector is here, I'm gonna call Fr, our resultant force, and here will be our angle theta. So I know my magnitude of Fr square is equal the sum of forces in x square plus the sum of the forces in y square. I can put the modulus or not, it won't make any difference because you're just interested in the value. So Fr square is equal 66.3 square plus minus 13.3 square. I have my resultant force is equal 67.6 pounds. And now to find my theta, here is our sum of forces in y. I can do the tangent of theta is equal the sum of forces in y over the sum of forces in x. I have my tangent theta is equal minus 13.3 over 66.3. I know my theta is equal the arc tangent of minus 13.3 over 66.3. If you're gonna put this in your calculator, you're gonna find minus 11.3 degrees, but our final answer will be 11.3 degrees because the question asks from x-axis measuring clockwise. So this is our final answers. My magnitude is equal 67.6 and my angle is 11.3. Thanks for watching till the end. Don't forget to subscribe and share with your friends. See you in the next class.